Started again here at the keynote stage, so please put on your headset. Welcome back. So it is my pleasure now to introduce the next keynote speaker, Nicklas Brendborg. He's a Ph.D. student at Center for Active Living, Active Health at Rigshospitalet, and he's a best-selling author. Today he will explore why it's so difficult to break habits and how we can take control over our behavior. So please welcome.
Good afternoon, everyone. I've not tried doing this with the headphones on, so if I speak too loudly or too low, just please indicate and I'll change. Higher up? Yes, a little bit higher up. Okay, so I'm Nicklas Brendborg, I'm 29 years old, and I am a PhD student in my daily life, but I'm also an author. Among others, I've written this book, Gopler Ældes Baglæns in Danish. It's called Jellyfish Age Backwards in English, and it is about the science of aging and on longevity in general. So this is a book I'm going to be speaking about today. Of course, I can't tell you all the stuff that's in this book, although I would have liked to. So instead, I've taken out a few topics. So we're going to talk a little bit about aging as a phenomenon. What is it? Why does it happen? Why I think it's the most important topic in health, bar none. And then also a little bit about what can be done if you wanna fight the aging process. And then, given that we're sitting here on a Sunday, I also brought a little quiz that you can participate in if you want to. This is completely anonymous, so I can't see what you answered. The person next to you can't see it either. It's just a consensus from the whole crowd. So if you want to join, there's two ways. You can scan the QR code, or if that doesn't work for some reason, you can also just go into slido.com. There you're asked about a password, and the password is jellyfish. So I will put this up every time there's a question in the quiz. So even though it doesn't work in the first time around, you can also join later. Because I want to start my talk with a little question. Now that we're going to talk about living a long life, it makes sense to look at what is it actually that ends our life. So in Denmark, just as an example country, what is the most common cause of death? Is it lung diseases? Is it cardiovascular diseases, so something like having a heart attack or a stroke? Is it cancer, or is it dementia? So if you're not in the quiz, there's still the option to join, and otherwise it's also perfectly fine just to discuss if you brought someone here and you want to make sure you get the right answer. So maybe we can get the last couple of answers in. And the correct one is that a lot of people need to quickly change the answer to cancer, because that is actually the correct answer. So if we were in pretty much every other country of the world, you could be right that cardiovascular diseases is the most common cause of death. That's true globally, but in the most developed countries like Denmark, we've actually seen the incidence of cardiovascular diseases going down, and then we've seen cancer going up. So if we look at the statistics in more detail, this is what it looks like. This is what is the most common cause of death in Danes. So we see still we have a lot of work left to do on smoking, because lung cancer is the #1 cause of death. So it would make sense, right, that we look at these diseases and then say, okay, if I want to live a long life, I should find out every single risk factor for all of these diseases, and then I should try to optimize them in my own life so that I can avoid them. So if we look at some of the risk factors, that is something that's pretty well known at this point for a lot of people. We can see if you are a smoker, you have an increased risk, not just of lung cancer, but of several types of cancer. There's stuff like drinking too much alcohol, being obese. For cardiovascular diseases, there could be something like having hypertension. And that stuff you can learn a lot about. There's a bunch of brilliant people that can teach you how to optimize these risk factors, and of course that's very worth doing. But there's one risk factor that I didn't put up here that actually makes all of these pale, and that is aging. So this represents the risk increase from going from 25 years of age to 75 years of age. And we can see that you can be 75 years old and live the perfect life according to health authorities. So you can eat correctly, exercise, don't smoke, and so on. And your risk of all these diseases will still be vastly higher than someone who's my age, who doesn't care about their health at all, who just smokes, sits at home, eats junk food, and so on. So it follows from this graph that it's, of course, really a good idea to optimize all of these things. But if we really want to make progress on these diseases, we should try to see if we can find out what is it that goes wrong when we age, and is there some way where we can at least break this process? Because if we could slow it down, we would have a lot more time in a healthy body, but we would also decrease the risk of a whole bunch of different diseases at once. So that's what I'm researching. I'm trying to find out what is it that goes wrong in aging. But of course, when I talk about this stuff, some people will be a little bit skeptical. They will say, well, isn't it just a law of nature that we have to age? Isn't that just something that you have to contend with? Because it happens to every single animal on Earth. So that is the first skepticism I would like to address. Is there actually anything we can do to the aging process? So to take a look at that, we're going to go on a little detour. We're going to go to this part of the world, the ocean around Iceland and Greenland. And there you can be very lucky to meet this absolutely fascinating animal, which is called the Greenland shark. And the Greenland shark is this 5 to 6 meter long shark that for a biology nerd like me is just the most fascinating thing you can study practically. And the reason I think this is such a fascinating animal is that this is just an example of an animal that's weird no matter what attribute you look at. So if you look at the eyes, you might see that it doesn't look like it has the best sight. That's actually because it has these small parasites that live inside its eyes that slowly eat the eyes and that makes it go blind. Then also, this shark, if you wanted to eat it, it has so much of a toxic substance in its flesh that you actually become what's called shark drunk from eating it. So you get like dizzy, maybe a little more fun to be around, and you definitely need to sleep until the next day before you're totally on foot again. But unfortunately for these sharks, they share their habitat with the one nation that is not so scared of eating stuff that we don't consider food, the rest of us, so that's Icelanders. And actually, this is a delicacy on Iceland. So what they do is they dig this poor shark after it's been killed down on the ground, let the meat sit there for a few weeks to become really nice, kind of rotten, and then they take it up and they give it to their friends and family. So this has actually been described by the deceased chef Anthony Bourdain as the worst meal he ever got in his entire life. But if there's something good about it, it is that when these fishermen catch these sharks, then it's possible for scientists to study them. So there was some scientists from the University of Copenhagen, led by Julius Nielsen, who took one look at this shark and thought, this looks like an animal that just lives a really long life. So they went up there to actually try to study how long these sharks can live. And their best estimate is that these sharks live around 400 years. Now, if we're being really optimistic, their study actually allows for there to be 500-year-old sharks as well. So I brought a little timeline just to illustrate how long that actually is. If we were so lucky to meet the oldest of these sharks, it would have been born in the beginning of the 15th century. Then by the time the United States was founded, this shark wasn't even longer than halfway in its life, and then we see that it has its whole old age up in our modern time period. So of course this is not to say that a Greenland shark and a person are that closely related, but then again, a Greenland shark has a brain just like us. It has a cardiovascular system, it has a liver, digestive system, and so on. The difference just is that by the time our brain is completely done because of aging, this shark just is still really fresh and young, and it can last for at least several human lifetimes more. So this is an illustration that we might not know if it's possible to live forever, if it is something that, biologically speaking, you could actually do, but we know that you can live at least several times longer than the average human does today. And the Greenland shark is not the only example of that. We also know stuff like the bowhead whale, which lives actually quite close to the Greenland shark, which lives about 200 years, and that's a mammal like us, so now we're really getting close to human biology. On the other hand, we also know a lot of mammals that really, really don't live as long as us. So for instance, if I'm doing a study on a mouse in the laboratory, such an animal will usually live 2, maybe 3 years. But the interesting thing is then, if we look at these different animals, it might take a very long time or a very short time for them to age, but the end destination is actually the same. So here I brought 2 dogs that have been photographed with 10 years in between, and you can see that at least one of the signs of aging is exactly the same as we know from humans. We see that the hair is starting to turn white or it's graying. That's something you see in all mammals, but if we could look inside these dogs, we would also see loss of muscle mass, loss of bone mass, decline in cognitive functions and decline in brain mass. We would see a decline in the immune system. And a lot of the changes that happens with age that we know from humans is actually also happening in this dog. It's happening in a mouse, but in a mouse it's 2 years. In 2 years, we're seeing it in a bowhead whale just in 200 years. So we're trying to study all these animals to find out if aging is the same practically, why does it happen in such different speeds? And there's way too much to talk about in that area. There's a lot of things these animals have in common, but I took one of them with me today because one of the easiest rules to understand is that it seems the larger an animal is, the longer it tends to live. So we tend to see something like a whale or an elephant live a very long life, and something like a mouse live a very short life. That being said, I also brought these 2 friends, a Great Dane and a Chihuahua, and then the next question in the quiz is, which of these dogs live the longest? Okay, let's get the last couple of answers. And the correct one is, of course, a Chihuahua. So if you have a love for bigger dog breeds, you might know that a dog like a Great Dane will usually live something like 8 years, maybe 10 years if you're very lucky, whereas a Chihuahua can easily double that, and we also know Chihuahuas that lived into their 20s. So how does that fit the rule that larger animals are supposed to live longer? Well, it turns out there is a little twist to this rule, that it's the opposite way around if we look within each species. So small dogs live longer than large dogs. Ponies live longer than horses. The longest lived mouse ever is what's called an Ames dwarf mouse, which is like half the size of a normal mouse. And then usually at this point in my talk, there will be some people in the crowd that'll just look down their long legs and then wonder, is this also true for humans? And I promise we will get back to that. Good. So now we know that aging can take a long time, it can take a short time, but we tend to end up in the same spot. But this attribute of taking different time, of having different timelines, is actually not the only way that aging differs if we look into nature. So it turns out that there's also vastly different patterns of aging. If we look at human aging, it's this gradual process. So you will see your looks change, your muscle will atrophy, and you can maybe do the same stuff that you could do 10 or 20 years ago. But if we look at other species, they don't necessarily have this same gradual pattern. For instance, if we look at something like a salmon, it will go through its entire life without aging, and then it will take the entire aging process in 1 week at the very end of life after it lays its egg, and then die. We could also look at something called something like the lobster, which practically don't age. So a lobster, when it grows older, it just grows bigger, stronger, more fertile, all the way until the last of its days, where it will usually die if it hasn't been eaten or something. It will just die from becoming so big that its physiology can't actually support it any longer. So there's all these different ways of aging, but the most interesting one, in my opinion, is the one that my book is named after, and that is this little jellyfish that not only ages slowly or not at all, but can actually age backwards. So it looks like this. It's not the most interesting animal in the world if you just observe it without having any prior knowledge. Basically, it's the size of a fingernail and it swims around eating plankton, and that's practically it. But if you know just what to do to this jellyfish, then you can make it reveal its magic. So you have to stress it in some way. You have to increase the temperature in the water, maybe increase the salinity. You can also damage it by having a little knife and making a little cut into its body. And if you do that, you can make it go from this, which is a adult stage, back to something called the polyp stage. So that would be akin to taking a butterfly and turning it into a caterpillar again. It would be practically akin to taking one of you guys and then turning you into a kindergartner again. Then it can grow up anew. Then you stress it once more and it goes back, and you can just make it go around in this circle practically forever. At least no one has found a limit to how often you can do this at this point. So that means if we keep this away from predators and we actually keep stressing it just a little bit, you could argue this is an example of something that is basically biologically immortal. So an animal that could live forever. Now, we are not a Greenland shark or bowhead whale, so if we're going to talk a little bit about humans instead, that is of course stuff that's a little more applicable or something that's a little closer to being feasible today. Human aging is not backwards, it's also not like the lobster. You can illustrate it in many ways, but the simplest way, in my opinion, is simply to say, as time goes on, we have an increased risk of death. So if you look at this graph, you see if you survive being born, then the safest part of being a human is being a child. Then actually, as soon as childhood is over, at least when puberty finishes, then you start biologically aging, and then we see the risk of death just increasing. So approximately every 8 years after puberty, your risk of death will approximately double. And that means when you're my age, maybe you haven't started feeling it yet because you start from such a low level. But as time goes on, each of these intervals become more and more noticeable. And actually, I have a little bit of a sad point from this slide for that reason, because I get a lot of questions from people that say, I have a goal of reaching 100. How do you think I fare? I eat all of these nice foods? Here is my exercise data. Don't you think I have a good chance at making it? And I just have to say, unfortunately, if you have a goal of reaching 100 years, you're not halfway once you reach 50. You're halfway when you reach 93. So that means it's as hard to go from 93 to 100 as it is to go all the way from 0 to 93. And that's, of course, because we are fighting this exponential decline in all our physical functions. That just means it gets harder and harder and harder to stick around. Fortunately, there are people that still totally break this curve, and the best example is this lovely lady, Jeanne Calment, who has the world record for the longest lived person we've ever registered. So, of course, there are people that claim they live 200, 300, 500 years, but here we have birth certificate, death certificate. We have a lot of pictures from her life, so we know, at least for sure, that we can make the human body go for a little more than 122 years. So that should be like the first goal we have. We know human physiology is capable of that. So now, if you ask Jeanne Calment what her secret was, she actually claimed herself that her longevity was due to lots of red wine and lots of chocolate. I don't know, as a representative of Rigshospitalet, whether that is the best piece of advice. But there is one interesting thing about her that's not mentioned a lot, and that is even before she started shrinking from age, she was a very, very small woman. So she was 150 centimeters tall. If we go down the list of the longest lived people ever, first of all, we'll notice that they're all women, and they have heights such as 147, 152, 143, like really, really short people in general. And why is that? Potentially because we have the same rule in humans as in all other kinds of mammals, that we can see if you are small, you tend to have a little higher chance of living a long life. And that doesn't mean you have to be like, crap, I'm tall, now I'm gonna die early. Of course, we both know tall people who lived a long life and short people who died early. But it just seems there is something to do with growth signaling and growing in general that is also tied somewhat to the aging process, and we can get back to what that is. So I also brought a little timeline for Jeanne Calment, for her life, just to illustrate how long she actually lived, because it turns out when she was born, Hans Christian Andersen was still alive. Then when I was born in 1995, she was actually still living. If you need another point, that I also put in Euro 92. So that's just to say there's a single person who could have been held by Hans Christian Andersen when she was a baby, and then could have maybe been wheeled into the stadium in Sweden, in Gothenburg, when Denmark won the Euros in 92. So you can just see, even though we might not be so close to living as long as a Greenland shark, for instance, if we could just reach what we know is humanly possible, then you can have a crazy life where you can see everything change. So that would be the first goal. Unfortunately, then if we look at how lifespan data is progressing, I've brought an overview here of the global life expectancy and then the longest lived person. Because if you remember back to Jeanne Calment, she died in 1997, so that would be when I was 2 years old. Since then, we haven't had a new record holder, and the oldest person today is 116, meaning that if we're gonna get a new record, it can't be before 2030, and most likely this person is not gonna make it, so it's gonna be even further out. So it seems that we have really had a lot of progress in taking the average person and making them live longer, but the top level of what is achievable by a human has practically not changed at all in all of the time I've been alive. So that is a special focus area for aging research, where we can say a lot of general medicine will help us push us up against what is actually possible, but to achieve a longevity that is beyond what seems to be humanly possible right now, we need to dive into aging, and we need to understand what is actually happening. So what is the plan to do that? That is to do aging research, and so far we have talked about aging research that looks kind of like this. You go into nature, you go into society, you try to find a long-lived animal, maybe a person that lived a long time, preferably, of course, several people, and then you study them and you try to find out what can we learn. Maybe is there something that these people do that we all could start doing. But another part of aging research is what you could call interventional, and that's aging research where you then say, now we've learned a lot about aging, can we then apply this? So can we take an animal and actually make it live longer? That would imply that we actually know what's going on and we're on the correct path. So I brought a picture of the animals that we usually use in aging research. Then you see the average lifespan and the record lifespan. Maybe it's not so clear for the people in the back. But usually what you do, you start doing an experiment on a fly, maybe a worm or something that doesn't live very long, and then you go to something like a mouse or a rat, and potentially even to a dog or a monkey before, of course, in the end, you want to go into humans. And what I find most interesting is to try to work with mice, because, as I said, 2 to 3 years is a normal lifespan of these animals. So in relatively short time, you can see, can we actually give them a drug? Can we do something to these animals that make them live longer? And we can. There's more than 100 ways to actually make mice live longer. I brought a little overview here. It might not be the most applicable if this is something that you're interested in trying at home, but we can get like some interesting ideas about what aging is. The very record holder for the longest lived mouse, as I told you, is mice that are really, really short or really, really small. So you go in and you restrict the ability to grow, then you just tend to have mice that live very long. Then there's something called VEGF overexpression, which is basically increasing the amount of blood vessels that is made in the body, because we think one of the reasons we lose bone mass, we lose muscle mass, we lose brain mass, is basically that we get worse and worse at actually supplying nutrients and supplying blood to the various tissues. So if you help move this along, then you have some benefits. Then there's a bunch of other stuff that I describe more thoroughly in the book. It can be a little complicated to understand, but basically this is just to say there's a lot of different ways to prolong the life of mice. So hopefully some of this will apply to humans. Then some of this stuff might be a little hard to transfer, but there is actually a branch of mouse research where researchers try to take drugs that are already approved and then try to see, can we then make mice live longer if we give them these drugs? So this is the gold standard for mouse longevity research. It's something called the Interventions Testing Program. It's done in the United States. Basically do 3 experiments at the time where you do 3 independent flocks of mice and then see if a drug can extend the life of all of them. And most drugs can't. Something like, maybe some of you guys have heard about metformin as an anti-aging drug. That doesn't extend the lifespan of mice. Resveratrol doesn't either. But here are the top record holders for this program. A drug called rapamycin. Then we have a diabetes drug called acarbose. Then interestingly, there's something called 17-alpha-estradiol, and that is, as the name suggests, actually an estrogen, but it's a non-feminizing estrogen. So if you give it to male mice, they don't start displaying female characteristics or behavior, they just live longer. And weirdly enough, it doesn't really work in female mice. So usually the female mice will live longer than the males, but if you give them this estrogen, the males will actually outlive the females, and it doesn't even help in the females. Okay, so these things are what is in the pipeline. I wouldn't recommend trying a lot of this stuff at home from the previous slides because it's tested in mice, it's not necessarily verified in humans. However, we do have some evidence from humans, and what we have the most evidence for is a phenomenon called homeostasis, which is actually absolutely central in aging research in general. It basically works the way that if you stress an animal a little bit, it tends to actually have a beneficial effect. So we might have an idea that if we want to live as long as possible, we have to really take care of ourselves. Nothing should stress us. We should never strain our bodies. But actually, if we look into the stuff that does extend lifespan, a lot of the time it seems to be a little bit toxic or a little bit damaging, at least in the short run. So a very easy way to understand this is that if you want to live a long life, right now, the best thing you can do is to exercise regularly. And that's something a lot of people know. We can see in this study, they have looked into people's cardiorespiratory fitness and then tracked them. What is your chance of them then having died in the following 10 years? Well, the better fitness, the lower risk of death. But if we think about what happens if we're out for a run, for instance, we get a high blood pressure, that's not very healthy, like in isolation. High pulse, that's not very healthy either. We damage our bones, we damage our muscles to support our weight. We strain our lungs to suck in extra oxygen. And in the short while we're running, we're actually breaking down the body. That's why it doesn't always feel nice, because we're actually imparting damage on ourselves. But then if we wait, then when the body sees all this damage, it basically takes it as a sign to invest more energy into repair and into strengthening various tissues. So that means in the long run, we get stronger muscles, stronger bones, stronger heart, and stronger lungs, and then we are actually better off in the end. So a lot of the stuff that you can actually do is about this phenomenon, but it can be a little abstract. So I brought a little illustration just to show how powerful something like exercise can actually be. What you see here is a scan that's taken in an American study down through the thighs of a person. So we see at the middle there's a strong bone. This person is a triathlete, so it's really, really a healthy individual. All the gray stuff is muscle, and then there's a little layer of fat underneath the skin, which is something that all of us have. So this is like the best you can imagine. Then in the same study, they also found a person who's not only not active, but it's also a person who who is suffering from aging, and that person looks like this. You see weak bone, very little muscle left, and lots of fat. So this is an individual with quite a high body weight. If this person is unlucky, maybe he trips over something, then when you trip over something, you have to be able to catch your whole weight just like that without any warm-up or anything. When your muscle looks like this, you'll have a tendency to not be able to do that. Then you fall, and then when your bone looks like that, you have a big tendency to just break your bone, and that's one of the biggest risk factors for an imminent death. If you're older, it is a very, very, very bad time if you break a major bone, because it can be hard for an old body to heal. So in the same study, they also found someone who's the same age as this guy, but he is just been exercising regularly, and this person still looks like this. Lots of bone mass left, lots of muscle mass left. And this is not to say that you can completely avoid losing bone mass or losing muscle mass. It's just to say that in a lot of the traditional textbooks on aging, they have had to be rewritten a little bit just to take into account that a lot of the people that grow older now has just taken a lot better care of their bodies than people used to do. So we can see that you can actually extend healthy life a lot longer than we thought. You can have your muscles and your bone working properly. It just takes an effort, and you, of course, have to start at a relatively early age to gain all of the benefits. So exercise is one form of hormesis, damaging yourself to become stronger. We have lots of other examples of the very same phenomenon. Maybe someone today have been talking about stuff like going to the sauna. If you do studies on it, you would usually call it heat stress in animals. You expose them to short periods of heat. In itself, that's damaging, but in the long term, it can actually help a lot of laboratory animals live longer. And we know from Finnish studies that people who go to the sauna a lot have a lower risk of cardiovascular diseases, they have a lower risk of Alzheimer's, and of an early death in general. So again, something you damage yourself in the short run, but it might be beneficial in the long run. Then something called calorie restriction is actually the best way to prolong the life of a mouse. What you do is you give it all the vitamins and minerals it needs, but then you just cut the amount of calories a little bit. If you do that, then you will prolong the life of the mouse. If you then cut a little bit more on the calories, it will live even longer, and so it goes all the way until it's practically starving. Then that's the mouse that lives the longest. So not the nicest thing to do, but just another example of the same phenomenon. And then in the end, we know from Danish register studies that people who donate blood in Denmark tend to live longer than those who don't. That could be because blood donors are already healthier, but we can actually see if we only look at blood donors, the more times you donate, the more of this benefit you tend to get. And that is most likely because this is just another way that you can stress yourself a little bit that can then help you live longer in the long run. Okay, so sometimes when I talk about this phenomenon, afterwards I get these very creative questions where people have found all these various ways that they can harm themselves, and then they want to know if that is then beneficial. So should you start smoking a single cigarette a day just to train your lungs to be extra hardy? And of course, no. What is really important to understand here is the damage is damage. So it's not good, and it's never good to damage yourself. But just in some cases, when you damage yourself, you turn on a response that makes you stronger. But it's not every tissue in our body that has the same capacity to heal, and it's not all types of damage that we can heal. For instance, our brain is really, really bad at healing. So that means if I hit my head really hard into this wall, that's not gonna somehow do a hormetic trick and making me more intelligent. It's just gonna decrease my intelligence, and I'm not really gonna recover from it. So some types of damage we should seek out, but most types of damage, of course, we should try to avoid. So in the last question in my quiz, I brought 4 of the types of damaging things that we should try to avoid, and then the question basically is, which one causes the most amount of death in the world? Hypertension, alcohol, smoking, or is it air pollution? Okay, I think we should get the last couple of answers in. And the correct answer is, again, that we need some people to change. Because if we look at these 4 different types of stuff that you should avoid, this is the global death toll. So of course, drinking too much alcohol is not good. Air pollution is something we should seriously consider, especially if you live in a city like Copenhagen here, where it's a big problem. Smoking is self-evident, of course, it kills a lot of people. But the bottom one, hypertension, is actually something that is often overlooked because it doesn't sound that bad. So high blood pressure, is it really such a problem? But yes, it is a huge problem. It's one of the 2 biggest risk factors from cardiovascular diseases. So you remember the second biggest causes of death in Denmark. It's one of the biggest risk factors for getting dementia. And then we also just know from studies in mice that if you give mice hypertension treating medicine, it will actually prolong their life. So it seems that being hypertensive can actually also just make you age faster. So of course, this is something that we want to tackle. Like, how do I avoid having blood pressure that is too high? One of the things you can do is to handle your stress. Make sure that you're not stressed, because being stressed tends to elevate your blood pressure. But one thing I especially focus on, and I talk about it a lot in my second book, is that eating a lot of processed foods is one of the best ways to make your blood pressure just go sky high. And that is because one of the ways that you get high blood pressure is basically eating too much salt. So salt is actually absolutely vital. It's important for your brain, it's important for your muscles. But this is how much salt that our ancestors used to eat, approximately 1 gram a day. That's how much your body needs, so your brain and your muscles to function as they should. Then if we look at the average Dane today, so we're the slimmest people in Europe. We tend to have better eating habits than most other developed countries. But the average Dane eats this much salt in a day. And this is actually the average Danish woman. So given that men eat a little bit more, the number for men is actually 10 grams a day. Then if we go and see what about like the most unhealthy people, like the top 20% of Danish people, how much salt do they eat? And then we are going all the way up to 15 grams. So salt is very healthy. If you're active, you might even need more. Going all the way up to 5 grams is not associated with any health problems, but it's pretty self-evident that if you go from eating 1 gram, as your body is built to do, and then to 15, then anything can become kind of damaging. So is this just because we use a lot of salt when we cook? No, of course not. This is basically only due to the fact that we eat processed foods. And one of the ways, if you produce food and you want to earn a lot of money, one of the ways you can attract people is to add a lot of salt, because we are hardwired to like stuff that tastes a little salty. We're also hardwired to like other stuff, for instance, sugar. And paradoxically, if you have a food that has a lot of salt, if you add some sugar, then people can tolerate a higher amount of salt. So then you can make people even more hooked on your food. So if you're a food producer and you want to get a lot of customers, you just pour in tons of salt, you pour in tons of sugar, you pour in fat, you make all these adjustments that are meant to make people eat as much as possible. Then they have a huge risk of having hypertension, also of getting obese, and that will then increase their risk of both aging faster, but also all these diseases I talk about. So that is what I talk about in my second book. And this is what I brought for you today, but if anyone has any questions or want a book, I will be sitting over here in the book lounge. So could be either Jellyfish Age Backwards or it could be Vanedyr. Unfortunately, I don't have any of the non-Danish Jellyfish Age Backwards right now, but it's out in 30 different languages across the world. So if you don't speak Danish, you can probably find it on your local Amazon just by searching the name. But
We actually have 5 minutes.
Okay, I think we actually have time for one question up here, if anyone wants to or dares to be the one to
What
ask
a chance. We actually thought that we would not have time for any questions.
Yes.
But we do. So any questions? Yes, there is a really motivated arm there. Super.
Well, thanks for the talk. I actually asked kind of the same question yesterday to Jesper Olsen, and it's because both of you talks about the importance of strength and muscle, but also about turning down growth pathways. So I guess my question is, would you, because I'm a bodybuilder myself, would you rather see me, turning down the protein intake and perhaps building less muscle, or would you rather see me, maximizing the muscle? Well, what's the trade-off?
Yeah, I wouldn't say that you need to maximize muscle. So a lot of older people get a problem with declining muscle mass that makes your functionality kind of poor. But in general, we see if you make older people eat more protein, they tend to have a lower disease risk. So eating more protein tend to be good. Maintaining your muscle mass is good, but muscle is not the be-all and end-all for longevity. Like if you could only do one type of exercise, it should definitely be cardiovascular exercise. So it's like cardio and then comes muscle building. Of course, there's various ways to be a bodybuilder. Some bodybuilders will take the easy route and use a lot of growth-promoting hormones and stuff. That would definitely not be beneficial for longevity, but it is important to keep muscle mass, but the most important thing is actually to keep strength, because that's where it really falls. That once you lose your strength and your ability to actually do stuff, then you become sedentary. When you become sedentary, then everything else goes downhill.
Super, thank you. We have time for just one small question.
I think there's one there.
Yeah, we just need the mic and maybe some help. Super, thank you.
You mentioned heat exposure, but what about cryomask, cryochambers, winter bathing, cold showers and cold exposure?
Yes. So is cold exposure as good as heat? If you look at the animal studies, probably no. So both of them would be considered a form of like stress induced by temperature, but the reaction to heat and cold is not exactly the same. And if you look to model organisms, it just tends to work better if you use heat. So that's not to say that cold can't work or that it doesn't have benefits, but from a pure longevity standpoint, it tends to just work better, and we don't understand exactly why. And you have to also, of course, remember that when you look at fins doing the sauna, a lot of the times they do this contrast therapy where they do the sauna and ice bathing, and then they go between them.
Super, thank you very much. Let's give him a hand. Okay, we'll be back in a short while with a longevity panel debate, so stay tuned.